right, my cat is right on my lap. And if I'm not careful, she might wake up. I don't know. If anything, there'll just be a goofy edit in this video. And that's my cat disruption of the day. So what we're going to be doing is this is day one of solving trig equations. I'm going to give you, oh, she's waking up. I'm going to give you a basic overview today, and then we're going to look at more complicated ones next time is our plan for today. Before we really get into solving I'm going to show you this thing. There she is. There she is. She wants to learn about trig equations. All right. So she's leaving. She knows not to talk to me. When you're solving a trig equation, we did these on the oral exam. You got all of these answers. So if sine was square root of 2 over 2, we got two answers, one from right here and then another one from right there. So that's like the square root of 2 over 2 spots. If sine theta is -1, we got 3 pi over 4. No, it's 3 pi over 2. Dang it. Well, that's wrong. Let's fix that. There you go. 3 pi over 2. We get that point down there. The last one gets us these two answers for these two spots. 5 pi over 4 would be that point right there. And 7 pi over 4 is that point right there. But something weird happens when you do this on the calculator. And I didn't talk about this a while back, but I'd like to talk about it now. It's kind of existential ponderings, but it's like why the calculator gives you weird answers. So check this out. I put it in degree mode just so that you can kind of see a little bit easier like what's going on. But when we do the inverse sine of square root of 2 over 2, we get 45 degrees. Okay, that's the pi over 4, and we had to work out the other answer. That's fine. But when we do the other one, it gives us negative 90 degrees? Why is it giving us a value that's like back here? That seems bizarre. It gets even weirder too when you do the negative square root of 2 over 2 and you do inverse sine of that. You get negative 45 degrees. Why is it doing that? It has to do with one-to-one functions. Sine is not a one-to-one function. It fails the horizontal line test. And when it fails the horizontal line test, it can't have an inverse anymore. So when we draw this line for the horizontal line test, you would probably start it right there. But as soon as you reach pi over 2, then it starts failing because it starts going back down. It kind of went up and then it went back down. I don't know if that's going in the right direction. This way, mirrors are weird. But it fails the vertical line test. But mathematicians wanted more to work with because we had prime real estate back here. So inverse sine only exists in this narrow margin right there. Inverse cosine has a similar problem, but it was able to work in the positive area and never in the negative. But inverse sine, however, does have that. Important thing to note out of all of this is that if you're solving a trig equation, you should get at least two answers. But when you type into the calculator, you'll get one all the time. And it could give you a negative weird thing. And there's other times too where you're solving it, you should, like I said, should get two, but sometimes you only get one. So it varies. So we need to be careful. It's one or two. And in the case you're going to see in a bit, there might be more. Oh, dang it, my thing's a little the wrong size. Wait for a minute. There, fixed. I'm doing something different. So what we're going to do while you're watching this video, if you want, you can work on the practice. There's a longer video today. So my idea is that you can follow the your turn, my turn pattern where I'll do a problem, and then you do a problem. So you can pull up the practice aside from this video, do the problem with me, and then do your turn problem. So these two on the screen should match up. And then repeat, like you'll watch the next example, do the your turn problem. Watch the next example, do the your turn problem. That way you can kind of do the two at the same time. Up to you how you want to do it. If you want to do all the your turns at the end, that's fine too. But I do want you to do that. Okay. So we're going to start by solving trig equations, basically the same as what we did before, but with a little twist. So we have cosecant, but that's not one we did on the oral exam. We only did sine, cosine, and tangent. So we want to turn cosecant into something that we can do. So I'm going to pull up my identity sheet and I'm going to look for cosecant to be something that I can do. And hey, look, cosecant is 1 over sine. So let's replace that thing that I don't know how to do, cosecant, with something I do know how to do, sine. Yeah, I'm going to get a 1 over, but whatever. You win some, you lose some. So I'm going to swap that out with a 1 over sine theta equals -2. And now this is an equation that I can solve. I want to get sine out of the denominator, so I'm going to flip both sides, also known as multiplying both sides by sine and then dividing by 2. You can also just flip both of them. That's fine too. So it's kind of like taking the inverse, taking the -1 exponent of both sides. So you get -1/2. All I did is flip both sides. Hey, that's like our oral exam stuff. So I need the 2 quadrants where sine is negative. So sine is negative down here. Sine is also negative down there. So my reference angle for sine being 1/2, sine counts up, so it's the smallest one. So it's pi over 6. Then I just need the pi over 6 in the red quadrant and the blue quadrant. For the red quadrant, my theta, not Q, I keep running Q's. My theta is going to be 7 pi over 6. And my theta 2 for the blue one, which I totally changed to blue. Let's make that 2 look better. Is going to be 11 pi over 6. And that's just oral exam video stuff. If you want to check out the oral exam videos for more details about how to do that, please do. So now you can do your turn if you wanted, or you keep watching and then, so do your turn and come back, or keep watching. I'm hoping you're back. Now we're gonna do another one, but I'm gonna change something. Notice up here I wrote in general form. One of the things I always said on the oral exam, and people are like, well, why are you even saying that? I would always say this, where 0 is less than, between 0 and 2 pi is something I kept saying over and over. Well, why did I say that? Well, these sine and cosine, we also learned it goes on for forever and ever. So there's actually an infinite number of answers for these. So it could be 1, could be none, could be 2, or it could be infinite, depending upon what we're working with. So for this one, cosine of theta is the square root of 3 over 2. I'm going to do regular stuff. So we could have, let's see, 2 quadrants where cosine is positive. We've got one right here, and I'm actually going to write this as 2 separate ones, and you'll see why in a minute. And all right, there we go. So in this, my reference angle for this thing is, let's see, cosine counts down, so I've got pi over 6 again. So, So this one, pi over 6, nope, 11 pi over 6. And regular pi over 6. Now, what we were saying with the oral exam, because I was talking for answers between 0 and 2 pi, I can say words. That would be all we said. We would just have this one angle right there. But we could spin all the way around and get another one. And we could spin all the way around twice and get a third one. And we can keep spinning and spinning and spinning. And we could go backwards as well. Same thing with this one. Here's our first angle, but then we could spin around and stop again. So we need to add on these spins. So we need to add on 2 pi n. So that's adding on the additional spins that we could get. We also want to subtract, because we could go in the positive direction or we could go in the negative direction. Same thing with this pi over 6. So plus or minus 2 pi n. So we actually get an infinite number of answers. There's the variant for the quadrant 1 cosines and the variant for the quadrant 4 cosines. So we would say all of these things. So there's an infinite number of answers right here, and there's an infinite number of answers right there. A lot of answers. Really, you just keep doing what we were doing before. Slap a plus or minus 2 pi n on the end, kind of like with our asymptotes that we did last chapter. Okay, so now do the your term or keep watching. if you're keeping watching, I'm going to keep going. This one, all right. Now, this is another thing where, like, theta over 2, that wasn't on the oral exam. I don't know what to do. So let's take a look at our trig identity sheet so we can get rid of that thing, get rid of the thing that we don't know what to do. Before I do that, I'm going to clean this up because there's also a bunch of junk going on. We've got that square root of 3 and we've got that minus 3. I want to get them out of here. So I'm going to add a 3 to both sides because I want to try to isolate that cotangent. This is going to make my future work a little bit easier. You don't always do this. This is just something that you want to do sometimes. The next one, I won't do this. And you don't even have to do this. I want to get rid of that square root of 3. So I've got cotangent of theta over 2. I'm going to divide both sides by the square root of 3. So I got 3 over the square root of 3. Now, you might be tempted to rationalize that denominator, but this isn't my final answer. I'm just trying to clean things up. You can kind of think about this as messy work. So I don't want to do any more than that. Now I'm going to go to my identity sheet. And you'll see why I didn't want to do any more than that. So I'm looking for something with a cotangent and a theta over 2. Like having a tangent, like right here, that's something that I'm looking for, but it doesn't have that theta over 2. So I'm wondering if I can do better. We talked about theta over 2's last time. Oh yeah, we had tangents, but there's no there's tangents here, but there's no cotangents. So, what if we used both? What if we use the idea that tangent of theta over 2 is one of these three here? Let me grab my mouse. One of these three here, and the idea that cotangent is tangent's reciprocal. We could take one of these three and flip it, and it would be cotangent of theta over 2. So we're going to take one of these three fractions, and we're going to flip it upside down. I have to blow my nose. It's annoying. So now normally, we remember from last time, this is the one to use, but then we're going to flip it upside down and then it'll kind of look like this one. So let's use this one. And then when we flip it upside down, then we'll just have a nice one trig function on the bottom. It'll make it a little bit easier for us to work. So I'm gonna use this one. We're gonna use 1 plus cosine of theta, sine over 1 plus cosine theta, but we're going to write it upside down because we're using cotangent. So I've got 1 plus cosine theta over sine. So I'm writing that second identity upside down because I'm replacing cotangent and not tangent. Okay. So now this equals 3 over the square root of 3. Ace. All right. So now we've just got to try to isolate this stuff. So I am going to get rid of the fractions. So I will multiply by the square root of 3. Hi. So this problem got away from me. I hit pause and then started figuring, and it got gross. Yours, I'm going to make sure that it is good. And in fact, while I'm saying that, I don't even know if that one is good, but I will make sure that that one is good. So it might not match that one exactly, but it should follow kind of a more sensible path. Like it'll kind of fall apart much easier. What's going on here is this is what I tried to do. I believe I'm going to end the video about here. I said I wasn't going to simplify the radical, but I did simplify the radical just so that there were fewer things to deal with, because that thing simplifies very nicely to just the square root of 3. Check that on your own. Pause the video if you need to do that.
Then I got the two things equal to each other. This is a very big no-no. It's why I really don't like this problem, but I thought it's kind of interesting. Excuse me. I got 1 plus cosine theta equals square root of 3 sine. Here's where I got weird. I couldn't solve it, and I didn't know what to do. So last resort, I went to my graphing calculator, and I did it on Desmos. I tested on my actual graphing calculator first, but I think Desmos, you'll be able to see what I did a little better. So in red, you have cosine theta plus 1, so it's one side of our equation. So that's our one side. And then here's our other side, square root 3 times the sine. So really, our solution is whenever those two sides are equal, or whenever they meet. So you can see there's one nice point right here at pi. Those two meet at that nice point, so that is one of our solutions. Theta equals pi. The other one is a little bit weirder. Oh, well, cool. I actually didn't even check this. Desmos figures it out for me. You're so smart, Desmos. So at 1.5, they meet each other. It's at pi over 3. So if we go back to this, if you put in a pi over 3 for cosine, cosine of pi over 3 gets us square root of 3 over, nope, gets us 1/2. So we get 1.5. And then if you do pi over 3 for sine, so here, so you get 1 plus 1/2, that's 1.5. If you do pi over 3 for sine, you get a square root of 3 over 2, which times that square root of 3. You get square root of, you get 3 over 2, which is also 1/2. So it does work out very nicely. So our two answers for theta in this case are pi over 3 and pi. Yeah, so that's my answer. I'm sticking with it. Yours should be much nicer. Do it if you dare. If you want to just skip that one, that's okay. This next one is better. Final problem of the day. This one, I know it looks bad, but it is better. This one, I have sine squared. So you might be tempted to, if you go to your identity sheet, go away. I don't want to look at you anymore. If you look at your identity sheet, we do have a sine squared thing. So we could say sine squared is 1 minus cosine squared. That's something that we might do next time, but we're not going to do it today. Right now, we're actually pretty excited that everybody is just sine. So we should be excited about sine. So if you're looking at that sine double angle, you're going to swap it out with this. I'm not going to swap that out. I'm going to keep it just as it is right here. Because the way I'm thinking about this and the way I'm looking at this one is I'm looking at it as w squared plus 2w's plus 1. That's a quadratic that I can factor. I can factor it. Got w, got 3 terms and a plus in the back. Sine doubles up like a Wendy's double stack. It's w plus 1 and w plus 1. W was taking the place of sine x. And, well, here, one more step with this factoring. This is just w plus 1 squared. So if I go back to my trig version, this is really sine x plus 1 squared equals 0. Cool. So now let's try to get that sine by itself so we can solve it. I'd square root both sides. I get sine x plus 1. And we square root this, so we get plus or minus 0. Well, that's just 0, so I don't really need the plus or minus. But you should still remember it. Remember that plus or minus. So then we got to subtract a 1. So sine x equals negative 1. And then we would solve that. So sine x equals negative 1. So that's when the y value is negative. So that's right down here. So this is one of those cases where I only get one answer. It's just going to be 3 pi over 2. All right. So now either you've saved your practice to the end, so you're going to go and you're going to practice all these problems, or you're going to do your final solve of the day on your practice and then turn that in. And once everything's turned in,
I'll see you back in Zoom. Bye.